A pleasant day, class! In this video, I am going to discuss the first lesson of Inferential Statistics, which is the length of confidence and appropriate sample. Napag-aralan natin na ang parameter ang siyang nagde-describe sa ating population. Ang parameter na ito ay ang mga population mean, standard deviation, at variance. From these parameters, we can make a conclusion for our study. But, alam natin na hindi natin totally masusukat ang exact values ng mga parameters ng population. Since alam natin na ang population ay naglalaman ng napakaraming elements. Using inferential statistics, gagamitin natin yung mga samples na kinuha sa population para makapag-infer tayo or makapag-describe tayo sa population. Ang estimation ay isa sa mga process na ginagamit para makalculate ang population parameters by analyzing a small random sample from the population. So, may estimate natin ang mga population parameters like mean and standard deviation by using those samples. We have two types of parameter estimates, which are point estimate na nagre-refer sa single value, and then yung interval estimate na nagre-refer sa range of values na kung saan ang parameter value ay posibleng makapasok sa range na yon. Sa illustration na to, meron tayong population ng mga kababaihan sa buong mundo. And then, gusto nating malaman kung ano ang average weight ng mga kababaihan sa buong mundo. So, yung hinahanap natin dito ay yung mean ng population. But then, sabi ko nga kanina na hindi natin makukuha ang exact value ng population parameter katulad ng mean. So, yung mean natin dito ay unknown. Mayroon tayong paraan na kung saan ay gagamit tayo ng range of values of samples para kahit papaano ay ma-estimate natin yung population. Gaya nga ng sabi ko kanina, gagamitin natin yung mga samples in order for us to have an estimation. For example, sa 5 sample na nakuha natin sa population, meron tayong average na 45 kg. And then, kumuha ulit tayo ng sample na 200, nakakuha tayo ng average na 58 kg. And, kumuha ulit tayo ng sample na 500 mula sa population at ang average nila ay 60 kg. Sa mga sample means na nakuha natin mula sa iba't ibang sample sizes, makakapag-formulate tayo dito ng range of values na kung saan ay pasok doon ang true population mean na hinahanap natin. Ang range of values na kung saan ay magpo-fall doon or makakapasok ang true population mean ay tinatawag na confidence interval. Naka-illustrate ito sa ating normal distribution curve. Sa normal distribution curve na to, meron tayong upper limit value and then lower limit value na kung saan ito ang magiging boundaries natin. Tapos yung pagitan ng dalawang values na yon, ito yung confidence interval. So at any point in this interval, confident tayo na tama ang estimate natin sa true population mean. Aside from that, meron tayong tinatawag na confidence coefficient. Ito yung area outside the confidence interval. So, yung sa illustration na to, yung nakakakulay purple sa kabilang side, ito yung confidence coefficient. Ang notation niya ay alpha. In mathematical expression, ang alpha is equal to 1 minus C. Wherein yung C na yon ay yung confidence level na naka-express sa percentage. And then, yung notation naman sa boundaries ng confidence interval, ito yung negative Z sub alpha over 2 and then positive Z sub alpha over 2. The confidence interval refers to the probability that the population parameter will fall between a set of values for a certain proportion of times. The higher the confidence interval, the higher the chance you will get an accurate estimation of the population mean. For example, we have a confidence level of 90%. It means that confident tayo na 90% ng estimation natin ng population mean will fall between those range of values. We have three common confidence intervals na ginagamit: 90%, 95%, and 99%. Meron tayong katumbas na safe value kapag hinanap natin yung points ng boundary. Sa 90%, meron tayong 1.645. Sa 95%, meron tayong 1.96. And then sa 99%, meron tayong 2.576. The length of confidence interval refers to the absolute difference between the upper confidence limit and lower confidence limit. Yung mga limit na yon, yun yung boundaries ng confidence interval o kaya yung hangganan ng confidence interval. So, yun lang, susubtract lang natin gaya ng pagkuha natin sa value ng range. But take note, yung confidence limit na to, it should be in X variable, not in Z-score. For example, find the length of the confidence interval. Number 1, from 0.470 to 0.355. Of course, naka-absolute value tayo dyan. So, kahit na lower limit yung nasa kaliwa, hindi magiging negative yung sagot. It should be always positive. So 0.470 minus 0.355 is 0.115. And then number 2, from 0.835 to 0.475, syempre dapat yung mauuna is yung higher or yung upper limit. 0.835 minus 0.475 is equals to 0.36. Remember, hindi pwedeng maging negative yung sagot. It is always absolute, meaning positive lagi. Para makuha natin yung interval estimate ng population mean, meron tayong formula dito. Ang lower confidence limit natin ay x bar minus say sub alpha over 2 times sigma over square root of n, and then yung upper confidence limit natin ay x bar plus z sub a alpha over 2 times sigma over square root of n. So yung nasa module natin, mali yung formula doon kasi dapat yung nasa upper limit natin, yung nasa kanang bahagi, dapat naka-positive yan. Kasi nga dapat mas higher yan sa isa. And then yung haba naman ng confidence interval natin is equals to 2 times 7 sub alpha over 2 times sigma over square root of n. Wherein yung z sub alpha over 2 ay yung mismong z value na nakalocate sa normal distribution curve. And then yung sigma natin ay standard deviation. And then yung n yung sample size. Take note, we can only use this formula if we have a given standard deviation. Let's have an example. Find the length of the confidence interval given the following data. Standard deviation of 0.3, sample size of 70, and the confidence level of 95%. So yung step 1 natin, as usual, we are going to determine the given. Siyempre, yung given natin, standard deviation is equals to 0.3, n is equals to 70, and the confidence level is 95%. Let's proceed to step 2. Find for alpha over 2. Diba, ang alpha is yung confidence coefficient. And then, kanina sa illustration na pinakita ko sa normal distribution curve, yung alpha natin is equals to 1 minus confidence interval. So, substitute na natin, alpha is equals to 1 minus 0.95. Therefore, the alpha is 0.05. I-divide natin to sa 2 kasi per point yung kukunin natin na value. So, alpha divided by 2 is equals to 0.05 divided by 2, it will be 0.025. And then next step, we are going to locate the value in Z table. So, dito tayo magkakaroon ng kaunting problema since magkakaiba yung mga table na nagagamit natin. Kung i-consider natin yung whole area ng normal distribution curve, we are going to subtract the alpha over 2 to 1 o kaya naman ay isusubtract natin from 0.5. So, bakit kailangan natin isubtract yung alpha over 2 from 1 o kaya 0.5? Kasi, ang kailangan nating value ay yung greater part. Kasi, ito mismo yung nasa confidence interval. So, kapag ginamit natin yung whole area, bale, 1 minus alpha over 2 is equals to 1 minus 0.025, it will be 0.975. Or, if we are going to use the half area of the normal curve, we simply subtract 0.5 minus alpha over 2, it will be 0.5 minus 0.025 is equals to 0.475. So, may papakita ko sa inyo na dalawang table. Itong nasa kaliwang table, ito yung nasa module 3. And then, yung nasa kanang module, ito yung nasa module 8, yung ngayong ginagawa natin. Nasa sa inyo yon kung ano yung prefer nyong table, pero para isahang table na lang ang gagamitin natin, gagamitin na lang natin itong nasa kaliwa, yung whole area na reference. Pag whole area yung reference natin, again, magsusubtract tayo from 1. And pag ilolocate natin sa table, make sure na yung area sa 0 point na z-score, it should be 0.5. Ayan, nakabox yan. Dapat ganyan yung nasa taas niyan. And then, yung sa half area naman na reference, so kapag ito yung gagamitin nyo, isusubtract nyo yung nakuha nyong alpha over 2 sa 0.5. And then, kapag ilolocate naman sa table, make sure na yung area sa z-score na 0, it should be 0.0000. So, lahat 0 yan dapat. Ayan, yung nakabox na yan. Para hindi tayo malito sa mga table natin. And then, we are going to plot the area that we have computed. So, yung sa whole area reference na 0.975, so, hanap natin dito sa mga areas na to. Ayan, sakto siya. So, meron siyang 0.9750. And then, titignan natin kung ano yung katapat niyang number sa taas at saka sa left side. So, yung katapat niya sa left side, 1.9. And then, sa taas ay 0.06. Therefore, ang z of alpha over 2 is equal to 1.96. And then, kapag half area ang reference natin na 0.475, kapag nilocate natin siya sa table, so, sakto din siya, 0.4750. Kapag hinanap natin yung katapat niya sa taas at saka sa left side natin, ang katapat niya ay 1.9 and then sa taas 0.06. So, same lang sila dapat. Therefore, z of alpha over 2 is equals to 1.96. After mahanap yung z value natin, so, isubstitute na natin yung mga values sa formula. LCI is equals to 2 times 7 sub alpha over 2 quantity of sigma over square root of n. So, given naman na yung standard deviation at saka yung sample size, and then na-compute na natin yung z value. So, LCI is equals to 2 times 1.96 times quantity of 0.3 over square root of 70. The LCI is 0.1406. Therefore, the length of confidence interval is equal to 0.1406. So, let's have another example. Example number 2. find the length of the confidence interval given the following data. Ayun. Sigma is equals to 0.3, N is equals to 45, and confidence level of 98%. Likewise, yung step 1 natin, yung given. Sigma is equals to 0.3, the sample size is 45, and the confidence level is 98%. Step 2, ayon, yung alpha over 2, 1 minus 0.98. Bale, yung alpha is equals to 0.02. And then, we are going to divide this alpha to 2. Bale, yung alpha over 2 is equals to 0.01. Okay, step 3. Before na malocate natin yung value sa Z table, we are going to subtract first the alpha over 2 from 1 o kaya ay 0.5. So, kayo yung pipili kung ano yung magiging reference nyo kung saan kayo magsusubtract. So, 1 or 0.5. Kapag ginamit nyo ay 1 minus alpha over 2, bale 1 minus 0.01, we will get 0.99. And then, kung 0.5 naman minus alpha over 2, it will be 0.5 minus 0.01, we will get 0.49. And then, we are going to plot the area in the Z table. So, it depends on the area na ginamit nyong reference. Kapag whole or 1 minus alpha over 2 ang ginamit nyo, ito yung gagamitin yung table ulit. Ito yung nasa module 3 So, kung napapansin nyo, di ba naghahanap tayo ng 0.99 sa mga areas na to. Wala tayong nakitang exact value. But we have to find the value na pinakamalapit sa 0.99. So, alin yung mas malapit sa 0.998 at saka 0.9901? Siyempre, yung 0.9901. Ito yung mas malapit sa 0.99 kasi ang difference niya lang ay 0.0001. Unlike sa 0.9898, ang difference niya sa 0.99 ay 0.002. So, mas pipiliin natin yung mas less yung difference sa 0.99 which is 0.9901. So, same lang din sa 0.49 na reference. Ang dalawang values na pwede nating pagpilian ay 0.4898 and 0.4901. Again, yung 0.4901 ang pipiliin natin dahil mas malapit ito sa 0.49 or mas less yung difference niya from 0.49. Therefore, kapag pat natin siya sa Z value sa taas at saka sa left side, we are going to have a Z value of 2.33. Then, substitute na natin yung mga nakuha nating value sa formula. Bale, LCI is equals to 2 times Z alpha over 2, quantity of sigma over square root of n is equals to 2 times 2.33 multiplied by quantity of 0.3 over square root of 45. Bali, ang LCI natin ay 0.2084. Let's proceed sa pag-compute ng confidence interval ng population mean kapag yung sample size natin ay less than 30. Kung naaalala nyo sa last module natin, module 7, meron tayong t-distribution na tinatawag kapag yung sample size natin ay less than 30. Kapag greater than 30 naman or saktong 30, ang ginagamit natin ay normal distribution, yung may mga Z tables at saka Z score. So, sa case natin ngayon, we are using t-value. Bali, ang magiging formula natin sa pagkuha ng confidence interval ng population mean will be from the lower limit, x bar minus t alpha over 2 multiplied by the quantity of s over square root of n. Then, in the upper limit naman, x bar plus t alpha over 2 multiplied by the quantity of s over square root of n. And then, sa length of confidence interval, same din ng sa naunang formula natin, but this time, gagamitin natin ay yung t-value natin. Bale, LCI is equals to 2t alpha over 2 multiplied by the quantity of S over square root of n, wherein the t alpha over 2 is the t value and S is the sample standard deviation. So, ito yung pinagkaiba natin sa naunang formula natin ng length of confidence interval. Kasi yung sa nauna natin, di ba, sigma yung ano doon, yung standard deviation. Yung sa unang formula natin ng length of confidence interval, ang given doon ay yung standard deviation ng population. But in this case, we will be using the sample standard deviation. And again, n is the sample size. Okay, let's have an example. Find the length of the confidence interval given the following data. S is equals to 6.5, N is equals to 15, and confidence level of 99%. So, yung step 1 natin, kunin ulit natin yung given. S or the sample standard deviation is 6.5, and then the sample size is 15, and then the C or the confidence level is 99%. Next step is to find the degree of freedom. So, yung process na to, same lang to nung sa module 7. Kapag hinahanap natin yung t-value kasi t-value pa rin yung hinahanap natin dito. Bale, TF is equals to n minus 1. Bale, 15 minus 1 is equals to 14. And then, find alpha over 2. So, ganun pa rin yung way natin ng pagkuha nito. So, alpha is equals to 1 minus confidence level is equals to 1 minus 0.99. Therefore, the alpha is 0.01. And then, we are going to divide this by 2. Bale, 0.01 over 2. And then, alpha over 2 is equals to 0.005. And then, we are going to locate this alpha over 2 sa t-table. So, wala tayong problema dito kasi same table lang naman yung gagamitin natin, yung nasa module. Yung nasa taas na part ng table, yung right-tailed area, yun yung alpha over 2 natin, yung nasa taas. And then, yung sa left side ng table, ayun yung degree of freedom, DF, which is 14. And then, yung right-tailed area natin, or yung alpha over 2 is 0.05. So, ipagtapat lang natin sila, and then, malolocate na natin yung 2.977. Therefore, the T alpha over 2 is 2.977. Since we have the T value and the given values, so isubstitute na natin. Bale, LCI is equals to 2 times T alpha over 2 times quantity of S over square root of N. Remember, yung S natin ay yung sample standard deviation. Bale, LCI is equals to 2 times 2.977 multiplied by the quantity of 6.5 divided by square root of 15. So, yung sample size natin, less than 30 siya. Therefore, if we are going to compute, the answer will be 9.9926. In the first part of this video, we have dealt with the computation of the length of confidence interval or yung range ng values na kung saan magpa-fall yung population mean natin. Dito naman, we are determining the minimum sample size needed when estimating the population mean. We have the formula of n is equals to quantity z alpha over 2 times sigma over e raised to 2, which derived from e is equals to z alpha over 2 multiplied by the quantity of sigma over square root of n, wherein the z alpha over 2 is the z value and the sigma is the standard deviation of the population, N is the number of sample, and E is the margin of error. So, in this formula, inintroduce dito yung margin of error. In estimating the population mean, may possibilities pa rin tayo na magkaroon ng error. Kung yung sa confidence interval, chance natin yon na makakuha tayo ng tamang estimation ng population mean within the range of values, yung margin of error, interval din yon na kung saan ay magkakaroon tayo ng failure sa estimation. Sa madaling salita, yung confidence interval, yun yung sukatan ng success mo, and then yung margin of error ay yung failure sa pag-conclude ng data natin. In this formula, makukuha natin yung appropriate na sample size na gagamitin natin kapag nag-estimate ng population mean. And then, the less error na makukuha natin sa pag-estimate. In this formula, the standard deviation is unknown. So, i-approximate natin yung standard deviation by using the formula of sigma is approximately equal to range over 4, wherein the range is the difference between maximum and minimum. Let's have an example. Christine wants to replicate a certain study where the lowest observed value is 10.4 while the highest is 12.8. She wants to estimate the population mean mu to within an error of 0.05 of its true value. Using 98% confidence level, find the sample size and that she needs. As usual, our first step is to determine the given. We have X minimum, which is 10.4, and then X maximum is 12.8. And then the margin error is 0.05, and the confidence level is 98%. The problem asks for the sample size. Since we need to determine the value of Z alpha over 2, let's find again for alpha over 2. Alpha is equals to 1 minus C. Alpha is equals to 1 minus 0.98. And then, alpha is equals to 0.02. And then, divide by 2. Therefore, alpha over 2 is 0.01. And then, before we locate this value in Z table, let's subtract it first from the reference of whole area or half area. If we are going to use the whole area, which is 1 minus alpha over 2, our new area now is 0.99. And then, if half area, 0.5 minus alpha over 2, therefore the value of alpha over 2 is 0.49 based from the reference of 0.5. Okay, let's locate those values 0.99 or 0.49. And then we are having a Z alpha over 2 of 2.33. The next step is to find the standard deviation of the population. So, yung kaninang formula, sigma is equals to range over 4, or sigma is equals to x max minus x min over 4. So, yung given, 12.8 minus 10.4, then divided by 4. So, we are going to have a sigma of 0.6. And then for the last step, substitute the values in the formula of n is equals to quantity z alpha over 2 times sigma over margin of error e raised to 2 power. And then, kapag sinubstitute natin, magiging n is equals to quantity of 2.33 times 0.6 divided by 0.05 raised to 2 power. Therefore, kapag kinalculate natin yan, bali ang n natin is equals to 781.76. But, ang hinahanap natin ay sample size. So, ano dapat ang numerical representation niya? So, yung number natin, dapat whole number siya. Kasi it refers to the quantity. Or should I say, discrete dapat siya. So, kapag merong decimal point, matik, we will rounded it off to the next whole number. So, dito sa pag-round off, hindi natin kailangan sundin yung rules sa pag-round off. Matik, pag may decimal, sa next whole number na natin siya i-round off. For example, we have sample size of 781.76. Kapag ni-round up natin siya, magiging 782. Kasi quantity yan, hindi yan measurement. Therefore, the sample size needed in the study is 782. Okay, let's have another example. You want to estimate the mean gasoline price within your town to the margin error of 5 centavos. Local newspaper reports the standard deviation for gas price in the area is 25 centavos. What sample size is needed to estimate the mean gas prices at 95% confidence level? So, yung given natin, meron na tayo dyang standard deviation. So, hindi na need computin yung standard deviation. Yung standard deviation natin dyan is 25 centavos. And then, yung margin of error is equals to 5 and the confidence level of 95%. And then, for the next step, dahil given ang confidence level, we are going to find for the Z alpha over 2. Yan. Bale, alpha is equals to 0.05 and then divided by 2. Therefore, the alpha over 2 is 0.025. And then, for the reference, magiging 0.975. And then, kapag half reference is 0.475. Kapag nilocate na natin yung 0.975 at 0.475, ayan, sakto naman sila. Therefore, ang Z alpha over 2 is equals to 1.96. Pwede niyong balikan yung mga naunang example natin para sa ganitong step. And then, for the final step, substitute na natin yung mga values sa formula. N is equals to quantity of Z alpha over 2 times sigma over E raised to 2. So, kapag sinubstitute na natin, magiging quantity of 1.96 times 25 over 5 raised to 2. So, kapag kinalcule na natin yan, bali yung N natin is equals to 96.04. Again, kapag may decimal place tayo, automatic, i-round off natin siya sa next whole number. Regardless sa kung ano yung number sa decimal places. Mapa 0.01, 0.02, 0.1, 0.2, 0.3, matik mag-round up tayo into next whole number. Kasi gaya ng sinabi ko kanina, the sample size is a discrete number. It is countable in whole number. So, kailangan talaga naka-whole number yung sample size natin. Okay class, I want to congratulate you all for completing 8 modules of probability and statistics. I hope you're doing great answering your modules. For any questions, feel free to message me. That's all for this day. Thank you for watching.